Hello all, this is Jayant Reddy. Today I'm going to cover the concept of list comprehensions. Just to start with, what is a list comprehension and why do we need it? Whenever we have a situation where we want to iterate to each element in a list and then take some decision or do some calculation on each element of the list, that's where potentially we use list comprehension. And list comprehension is a pretty neat way of doing it. But before doing list comprehension, I want to first go through the concept of map and filters. But because list comprehension is nothing but a combination of the concepts of map and filter. So first I would go through the concepts of map and filter, and then I would go into the list comprehension formal way with some worked out examples. Now let's take the concept of it. Okay. So now what we said was we have a list comprehension. This has a combination of map plus, right? Where do we use this map? So where do we use a map? Map is, let's say if I have a list called 1, 2, 3, 4, and I want to square each element of this list. What I'm going to write here is a function, and I'm going to write a function square, and then I'm going to pass on this list. Let's say this list is equal to L, and I'm going to pass on this particular. This is basically the concept. What this will output is a or generate, right, or class. This doesn't directly doesn't return list, right? Just to go through this more formally, this is the syntax of the map function. So you pass a function and you pass an activity. So this function is whatever activity I want to do on each of the elements of this iteratable. This iteratable could be a list, right? Now, what could be the, like, this could be a list, or it could be, a, let's say, a dictionary, right? Or any of those such certain kinds of things we could use to pass on, right? So now, as I have clearly explained here, it returns an item or a generator of an object of an class, and it doesn't return list. Okay. So now let's try to understand what this list can do. Right. So now we have a map function. So I'm going to say write function function square of the number square. So I'm going to say return square, and I'm going to pass some value x. This value should return x into x, which is x squared. Okay. So now what I would do here is I'm going to write a map function here. Function here. I'm going to, as I told you, I have to write a function and and then I have to pass a list, right? So now I am passing a function which is return square, and I'm passing a list which is L. This is the list I'm talking about. Okay, I'm passing a list. So when I run this, now let's see what happens. Right now you get this map, and this is exactly the thing I was talking about when it says that it returns a iterator generator object and of map class and not actually a list. Now, what do we do with this iterator? The iterator is usually the way we use in other concepts. We could just use them as it is. For example, I could say stuff. Before that, let me just save it to an object called map and say let me do it twice. So that we get two elements one after the other. This you get 1 and 4. Why do we get 1 and 4? So you get this first element which is squared, you get 1, second element you get squared which is 4. So 1 square is 1, 2 square is 4. Right? And now let's say for example, we could use it in loop as well. And I could say I. And here when we run this, we get 149 because the square of 1 is 1, square of 2 is 2, and square of 3 is 3. Now, you could also convert directly into a list. This is how you convert directly into a list. When you convert this into a list, what you get is 149. So now we know how to operate on each and every element of the list. All we have to do is a very simple thing is to pass a function which exactly defines what operation we want to do on every element of a list and then pass on the list itself. As a result of which what we get is the converted function. Okay. So this is all about the map function. Just to remind you what we started with, we said that list comprehension is a combination of map and filter. So first we understood map. Now we're talking about the filter. So filter is nothing but creating a sublist. What it means is like this. If I have a if I have a, so if I have some list which is, let's say, 1, 2, 3, 4, and I want to get only the even numbers from this particular list, right? So this is called sublisting. You can do it any numbers. You could take even, you could take odd, you could take first two numbers, you could take first three numbers, and each one of them will be a sublist. And in set theory says they become subsets. Okay, so now I have to do this. What I have to do here is I have to use this particular syntax. So what I'm going to pass here is a filter, right? And I'm going to pass a filter function, and then I'm going to pass a list. So what this does is this function is applied on each and every element of the list, and when this function is applied on the list, if this function returns true, it gets stored. If it returns false, it gets ignored. Okay, so that's what we want to do when we do the concept of the list, right? So the same thing out here. Now, what do is an iteratable? Iteratable could be a string, list, tuple, dictionary. It could be your all these things could be part of the iteratable. And it returns again, as in case of map, it returns an iterator generator object, which belongs to a class filter. Now let's see how this works exactly the way we have looked at map. So let's say if I write a function which says check percentage 2 is equal to 0. Two. Okay, so I have checked this given. Now write the map function, data function. So I'm going to write a filter. I'm going to pass a function. Okay, this is the syntax. So in this function, I'm going to pass the check even function. Okay. And in the list, I'm going to pass this list. Okay. Now when I click on this enter, see here you get here a filter object, an iterator, and a generator. Right? This is exactly the same way how we get in case of map function. So exactly the way we did it. Let's save it. You could directly use the function, but just for ease to write, I'm just writing it like that. Save it to the object filter so that it becomes easier for me to write it. Now, how do we read it? So we could simply say exactly the same way it works out here. I don't think there is any difference in the way because they work exactly the same. Filter right here is filter. And I remove this two things. And I say print object filter. See, it gives me 2 and 4, which is it gives me all the even objects. Right? Similarly, I could use a for loop. So now I could just print this object filter. Right, I get 2 and 4. Again, I could just convert them into a list. Simple. Yeah, this 2 and 4. So now, again, to start from the beginning, we said it is a combination of map and filter, the list comprehensions. So basically, we understood how map works and how filter works. Now let's do a combination. Since we have understood it, let's see how a combination works. And here I'm going to write program where so now this becomes extremely simple. I'm going to say map. Map requires function and list. The function here I'm going to write here is return square. Right? And the next function I'm going to write check if the element in a list is even. So I won't put this function, say I've written it before, I'm just using them. So I'm going to write here as return square, and then I'm going to run this. Let's not just see what it returns if I pass this. So that I can see the output. So if you see here, it has given me all the scripts. So now what do I have to change? I have to change the list. One that I have to do is just to make you understand conceptually is I have a list 1, 2, 3, right? First, I'll filter it and create a new list of even numbers, right? And then I square them to get 60. This is what I. So now, since I have to get a list of only two numbers which are even numbers, I'm going to pass a filter function. And what is that I'm going to say? I'm going to say check. Right? Now, see what happens is what you get is 460, and this is exactly the thing what you do. The maps, map and filter and combine. Now, how is it related to list comprehension? Is that list comprehension? If you really look at it, it formally it is given in this particular syntax. The syntax goes as follows: you have an expression which is nothing but action. Action, right? This action in the previous thing in the map, what we used was a square, right? Right? And this particular part is for the iterable. And this one is basically a condition. This is the action of the map. This is a map action, this is a condition. So we have expression. Iterable condition. What is the sequence of events? First, it generates items from the item list, which I'm calling it as an iterative. Each item, it passes through this function condition. If the condition is satisfied, it is selected. If it is dissatisfied, it is rejected. These two things will give me a sub list. And this sub list is acted upon by this expression. Okay, so what we get is this expression acts on each element of the sub list and we get a conclusion. Right? So let's see what we actually what we say list comprehension. So here is the syntax of the list comprehension. Here is the syntax of the list comprehension. Expression. Condition. Right? So let's say, for example, if I want to write, I want to get all the even numbers. Right? So what I'm going to say here is and then I'm going to write here as for I L, and I'm going to say if that's what the condition I'm going to I percentage to 0, then I'm just return the value. So when I hit on this, what I get is 2 and 4, and I could also do square of it. So I'm going to return I and I square. So which will give me the square of the particular number. So all the things that we have done here using map and routines, in that the same thing, instead of writing the functions to make it more readable, you could write it in functions also. So what that means is, let's improve this. I could say here as let's say if so I just write it in the function form, which is basically the most preferred way to write it because it really says that. So I'm saying if for all the elements in the list, if they are even number elements, if they are even elements, then return their square. That's all I'm saying. Right? So you exactly get the same thing as what we did. So let's take another example. Let's talk a Pythagorean triplet. Let's take another example of Pythagorean triplet. Right? So if I were to explain you what this means, before I go to the Pythagorean triplet, let me explain you this so that it becomes more clear to you. Right? So this list comprehension, this particular list comprehension is nothing but if I have to write in a standard for loop, this is how it works. Empty list I will take. If it is a then append it to the temp empty list, which I'm going to write as I. So this will only, if I just say it only appends the I, but since we want the square of it, I'm going to say return. See this? So these two things are exactly same. This whole four lines, if you see, gets squashed into a single line, and that's the power of the list comprehension. So let's take another example so that we are very clear on what it is, right? So here we are saying generate a Pythagorean triplet x, y, z, which is not written, but which is kind of a triple because there's a 3, 4, 5 is one set number, so you can write them as triple. So return a triple. Each of the numbers are between 1 and 50, so that they satisfy this particular condition. So this can be very simply written it as set. This is a tuple I have to return for x in range 1. For x in range 1, 50, for 1 range 1, and for z in range z in range 1, right? So now we have got the generator. So we have written the generator. So this basically will generate all the tuples, right? If I want to explain you what this does, is a very simple thing. So let me just make it small so that So if we just run this, see this, we get let's make it 3 so that we get 2 into 2 into 2, we should get 8. This is what is the generator. So this generator generates the numbers. So let's go back to where we were. So we talked about this part would generate all the this specific part will generate all the numbers in this for cascading or the nested for loop. This is the cascading or the nested for loop. And now we have to write the function. So y is equal to z. X squared plus y squared is equal to z squared. So, and so now that's all. So now if we just run this, see what happens. So like we get all the Pythagorean triplets between 1 and 50. See that? Now if you look at this 3 and 4, and 4 and 3, they are same, they're different. So now we could do different kinds of concepts in this. Is how do we kind of bring all the duplicates? Right? And that's a very simple concept. Is instead of writing it here, we should write it here as x, right? So which means that y is always greater than x, right? Greater than equal to x. And then here I'm going to write this. And if we can yes, right. So you see here that earlier we had many repetitions. Now we see that we don't have any repetitions. Right? So as I explained you, what this cascading force means. So this is nothing but this cascading for which generates a set of numbers, which is combination of x and y and z. How does this work? This is exactly the way this particular form looks like. So you create all that thing, and each of this set is now matched with this criteria. If it matches, they get saved. This XYZ gets saved in this particular list. Okay. So that is about the list comprehension. So now we have seen that there is a condition so far where we have a condition only in the right side of the list comprehension, which means that which is acting as a filter, right? Now the expression per se in itself could also be a condition. Like for example, if I say that, let's take this particular example. So if I just that, so now if I say that, now instead of really returning the squared numbers, uh, instead of returning the even numbers, I want to say whether that is an even number or not. Right? So for example, if I say it is even and if I just write this number, what it does, it simply returns 2 and 4. Right? Now, instead of returning 2 and 4, I want to write it as even and even. Right? So now we write this. If I say that, this is how this particular syntax works. Just be very cautious about it. Okay? So if I say that if I percentage 2, right, then I'm going to return else. I'm going to else I'm going to return else I'm going to return text. Just that if it works properly or not, let me remove the filter function. so that you understand this way. So now if I, whatever we got from this iterator, if it is an even number, if it is an even number, then it is going to print even. It's going to enter an even text in the list, else it is going to enter. So now so now you see here, you have odd, even, odd, even. So this odd, even. That's what it says. Now you could want to say for, I will put the filter also so that which means that it will only now return even. So it is pretty much clear because you have earlier itself you have taken only even numbers 2 and 4, and then you are trying to convert the even numbers into an even or an odd text. So that is what we are trying to do. So now just to summarize what we have done so far. So the list comprehension has a format of expression and the condition, and expression itself would have conditions. List comprehensions are very useful notation to combine map and filter, as we've already seen in detail. Each of them map and filter and how together how they make a list comprehension. So I hope this particular conceptual understanding of list comprehensions will help you. And thank you.